Arc length as a function. Suppose we want to find the arc length for any segment from A to an arbitrary x in the interval a comma b. If y equals f of x and f prime is continuous on the closed interval a comma b, then the arc length formula for s of x is the definite integral from a to x, the square root of 1 plus f prime of t squared dt. Notice that we have to use t inside the integrand because the upper limit of integration is now x. The derivative of the arc length function s of x is s prime of x, which is ds over dt. The derivative of the integral cancelled out by the fundamental theorem of calculus. ds is therefore the square root of 1 plus dy over dx squared dx, and this is called the differential arc length. For example, find the arc length function for the curve y equals x squared minus 1 over 8 ln of x, taking the point P 1, 1 as the starting point. In this case, we start with x equals 1 with no ending. The upper limit of integration is going to be an arbitrary point x. Y equals x squared minus 1 over 8 ln of x is the function f of x. In the arc length formula as a function, we need to rewrite f of x as f of t. F of t is therefore t squared minus 1 over 8 ln of t. The arc length function is s equals the integral from a, which is 1, to x, the square root of 1 plus f prime of t squared dt. But f of t is t squared minus 1 over 8 ln of t, and so f prime of t is 2t minus 1 over 8 times 1 over t. We often simplify the integrand before we set up the integral. The derivative is 2t minus 1 over 8t. We would need to square f prime of t. The square root of f prime of t is therefore the square root of 2t minus 1 over 8t. Multiply this out, we have 4t squared minus 2 times 2t times 1 over 8t plus 1 over 8t, the quantity squared, which is 1 over 64t squared. This is 4t squared minus 1 over 2 plus 1 over 64t squared. Pay attention to this trinomial and the square root of the binomial. The trinomial is the same as the square root of the binomial. 1 plus f prime of t, the quantity squared, is 1 plus 4t squared minus 1 half plus 1 over 64t squared, which simplifies to 4t squared plus 1 over 2 plus 1 over 64t squared. And we observe that it looks like the trinomial above, except that it is plus 1 half instead of negative 1 half. But the earlier trinomial is the same as the square root of the binomial. And so this trinomial is the square root of the binomial 2t plus 1 over 8t, the quantity squared. Using the arc length formulas as a function, it is the integral from 1 to x, the square root of 1 plus f prime of t squared, but 1 plus f prime of t squared is the square root of 2t plus 1 over 8t, and this is underneath the square root. Don't forget dt. The square root and the square cancelled out. We end up with the integral from 1 to x, 2t plus 1 over 8t dt. The antiderivative of 2t is t squared, and the antiderivative of 1 over 8t is 1 over 8 ln of t. We evaluate this at t equals 1 and t equals x. Plug in x, we have x squared plus 1 over 8 ln of x. Plug in 1, we have 1 squared plus 1 over 8 ln of 1. But ln of 1 is 0. And so this is x squared plus 1 over 8 ln of x minus 1. This is the arc length function starting at the point 1, 1 with the ending arbitrary x. If we want to find the arc length from 1, 1 to the point 2, f of 2, then we just simply plug 2 into this arc length function, because this arc length function computes the length from 1, 1 to any arbitrary point x. S of 2 is therefore 2 squared plus 1 over 8 ln of 2 minus 1. 2 squared is 4, 4 minus 1 is 3. This is 3 plus 1 over 8 ln of 2. This is the exact arc length, and it is approximately 3.0866.